Friends, welcome back to ElectriVerse, where every spark tells a story. Today we are entering part 6 of the VSD series, and from this part, we enter a zone where VSD control theory becomes real industrial engineering. In the previous episode, we deeply understood sensorless vector control. Today, we are taking it a level higher. Closed loop vector control and encoder systems. Closed loop vector is a technology that provides the motor with perfect speed, perfect torque, and even perfect position. In the industry, this system is mostly handled by senior commissioning engineers. Today's episode is important and will be explained deeply in simple language. Let's start. The very first question, why is an encoder needed? Sensorless vector control is strong, but it has some natural limitations. Accuracy is weak at very low speeds. Heavy load start can cause stalling. Torque control at zero speed is not possible. Position control is impossible, and there is a slight delay during sudden load changes. Real industry examples: cranes, hoists, elevators, extruders, printing machines, robotics, alignment conveyors. In all these, a common requirement is to give the motor exactly the right speed and sometimes to stop at an exact position. This accuracy is only provided by an encoder. An encoder is a sensor that measures the exact speed and position of a motor shaft. No matter how the motor runs, slow, fast, heavy load, the encoder captures every movement of it. Main types of encoders. 1. Incremental encoder gives pulses, simple, best for speed measurement. 2. Absolute encoder provides a unique digital code for each position. Memory remains safe even if power is off 3. Resolver, extremely rugged, perfect for harsh environments. The drive reads the encoder data and controls the motor in real time. Closed loop vector simply means the drive does not guess, the drive measures. In sensorless mode, the drive estimates the speed. In closed loop mode, the drive takes the real speed from the encoder benefits. Zero speed torque, perfect low speed accuracy, smooth heavy load start, instant correction on load change, stable speed, position control, closed loop vector, AC motor, gives behavior similar to a DC servo motor. Inside the closed loop vector drive, 3 loops always operate. 1. Torque loop, the fastest loop, reacts in microseconds. 2. Speed loop, medium fast loop, keeps the motor's RPM stable. 3. Position loop, the most accurate loop, used in printing, robotics, indexing. Together, these 3 loops make the motor ultra smooth, ultra stable, and ultra accurate. The flow of encoder feedback is simple. Step 1. The motor shaft rotates. Step 2. The encoder generates pulses. Step 3. Pulses go to the drive. Step 4. The drive converts these pulses into speed and angle. Step 5. The drive calculates the error. Step 6. The torque loop adjusts the current. Step 7. The motor instantly corrects itself. This entire cycle keeps repeating every millisecond. In sensorless mode, zero speed torque fails because estimation does not work at zero speed. In closed loop vector, the encoder indicates the exact angle of the shaft. This allows the drive to hold torque even at zero speed. What are the benefits? Listen. Crane load hold, hoist safety, elevator hold, conveyor rollback prevention, extruder smooth startup. This is the hidden superpower of closed loop vector. Closed loop vector heavy load start is unbeatable होता है. इसका रीजन सिंपल है. टॉर्क एक्यूरेट होता है, स्पीड फीडबैक एग्जैक्ट होती है, स्टॉल होने का चांस ऑलमोस्ट जीरो होता है और लोड चेंज पर इंस्टेंट रिएक्शन मिलता है. क्रेन्स, कन्वेयर्स, क्रशर्स, एक्सट्रूडर्स, सब में ये रिकमेंडेड सिस्टम है. द रियल प्लांट लोड नेवर रिमेन्स स्टेबल. In the closed loop vector, the encoder detects load changes instantly. The torque loop reacts immediately and prevents speed dips. Performance is almost servo level. Position control means simply to stop the motor at an exact angle. Closed loop vector plus encoder, these make the work completely precise. It is used in all these areas: indexing, packaging, pick and place, printing register, robotics, alignment systems. A C motor also achieves servo-level precision. Common reasons for encoder system failure: loose cable, shielding problem, EMI noise, oil or dust, encoder wheel damage, wrong PPR setting, incorrect A, B, Z wiring, supply voltage drop, mechanical misalignment. Symptoms include hunting, speed fluctuation, vibration, false trips, overshoot, position error. Encoder health and motor control quality determine the performance. Simple rule: incremental encoder gives pulses, best for speed control. Absolute encoder provides a unique digital code, retains position memory, used in high-precision systems. Speed, incremental. Position, absolute. Closed-loop autotune is more intelligent than normal autotune. Drive measures inertia, friction, torque constant, magnetics, phase alignment, back EMF, encoder quality. This makes the accuracy razor sharp. In a packaging line, the motor speed was continuously hunting in sensorless mode. What was the reason? Low speed, sudden load variation, high precision requirement. What is the solution? Enable closed loop vector, install encoder, tune speed loop, optimize torque limit. What was the result? Speed became rock solid. Hunting stopped completely. Accuracy plus minus 0.1%. Production reliability increased. If you understand closed loop vector, then you are unbeatable in the interview. Common questions: sensorless versus closed loop, role of encoder, speed loop versus torque loop, zero speed torque logic, incremental versus absolute, effect of PPR mismatch, reason for hunting, disturbance rejection, position control logic, solution to encoder noise. Friends, this was part 6 of the VSD series. A complete, simple, deep, and practical explanation of closed-loop vector and encoder systems. Today we understood encoder basics, closed-loop architecture, control loops, zero-speed torque, heavy load start, disturbance rejection, position control, encoder faults, auto-tune, case study, and interview questions. Now get ready. In part 7, we will enter PID loop mastery for drives. If you found the video valuable, comment on VSD or any topic you want a video made on, and subscribe to ElectriVerse. You've been watching ElectriVerse, where every spark tells a story. Stay charged, stay safe, stay happy.